Hello, everyone. Thanks very much for watching us. We are now on the technical session, which will be the last session before we go into the networking. This session will focus on the R&D projects and the technologies which are aimed to improve mining efficiency. I would like to introduce to you Chris Bray. He's a principal mining consultant, SRK Consulting UK. He's based in Bulgaria, and he will be chairing this session. If you have any questions, please do remember to post them on the chat on the website. If you haven't actually received the answer to your questions, you might actually want to go back to speakers' profiles, complete the form, and I'm sure the speakers will be very happy to reply to your questions in due course. I'll turn off my microphone and I'll make a final statement at the end of this session. Thank you.
Okay, just coming online. Thank you for the introduction there, Arthur, and appreciate all the support from the Menex team, including Irina, and the invitation to moderate this session. I noticed that there's not an official question and answer slot at the end of this session, so please get in touch with the individual presenters as you need to. This technical session includes a good range of presentations from equipment, service providers, consultants and research groups covering ventilation and conveying technologies, digitization and management tools for surface and underground mines, remote mine support services, recycling of mining waste products, and research and development projects focusing on mining efficiency. There's a common theme with the efficient use of energy and resources and equipment, and I'd like to introduce the first presenter, Pavel Bartak, from the Howden Ventilation Group. We haven't met directly, although I've been having some interesting conversations with his colleagues, Johan and Rory, earlier today in the chat rooms. Pavel is a mechanical engineer with the Howden Group for approximately 20 years and is the furthest away of our presenters, based in Quebec. He's been a key part of the development of the VentSim control software, and he's going to provide an overview of the opportunities for improving productivities, blast clearing times, energy savings, and most importantly, safety from a ventilation perspective. Presentation discusses the difference between ventilation on demand and ventilation optimization with a number of case study examples. I'll hand it over to you, Pavel.
Thank you very much. All right, so my name is Pavel Bartak. I'm with Howden VentSim Solutions, and today I'll present to you VentSim Control. I can't get into all the details, but I'll give you a good overview. So let's start off by looking at the difference between ventilation on demand and ventilation optimization. So ventilation optimization is, you could have, for example, controlling the fan speed manually, remotely, synchronizing two fans to run at the same speed, having a door open automatically based on gas sensor readings, having an airflow regulator open automatically based on airflow measurements, or based on scheduling. And then there's ventilation on demand. So what is ventilation on demand? It's basically an automatic calculation of the airflow demand based on a vehicle and personal presence in a zone. So how does ventilation on demand work? Well, we start off by using the mine's existing infrastructure, and then we take the vehicle positions, personnel positions, airflow measurements, gas measurements, and then send these to VentSim Control, which in turn calculates the air demand and determines the necessary fan and airflow regulator set points. These are then communicated to the hardware, where the PLCs and the remote IOs enable the remote control of the equipment such as fan starters, VFDs, and actuators. So with VentSim Control, you can maximize your production. So one of the optimizations is to be able to clear gases faster so you can get the workers in their zones quicker. We have an asset management system which optimizes the fresh air use, which gives you more capacity and flexibility for your vehicle fleet. The second aspect is to improve safety. So one of the major factors is improving the air quality. Then there's a whole system of managing different types of alarms. We can log all the system changes, and we assure compliance monitoring for safety regulations. The third aspect is energy savings. So we have different optimizations in the system where we can reduce wasted air while still attaining the airflow needs for all the zones, which then reduces the fan energy consumption. Then there's advanced controls where we optimize the optimization of the operation of the fans and the regulators. And we can typically get easily between 10 and 50% energy savings. There are some additional cost savings that can be also achieved with peak energy reductions or heating and cooling requirements reductions based on reducing the inlet airflow into the mine. So let's look at the 5 levels of control. Level 1 is manual remote control. Level 2 is automatic scheduling control. Level 3 is automatic flow control with gas sensor integration options. Level 4 is ventilation on demand based on tracking integration. And level 5 is advanced optimization, such as speed optimizer, total demand, and custom controls, for example. So let me give you a demo of the software. So here we have the summary page where we can see all of the controllers for controlling the fans and airflow regulators. So these summary pages can be customized with the number of controllers that you want to display. You can customize the columns that you want. And there's many different features, for example, filtering, where you can quickly see what's happening only, for example, which are in VOD mode. Or there's many different tools to be able to quickly see what's happening in your ventilation system. And this is where you can click on the controllers and bring up the faceplates to see the operating mode and the operating conditions that this fan, for example, is under. Okay, there's another way of visualizing the ventilation information, and that is through the 3D viewer. So, for example, here we have the Ventsim design model that has been imported in Ventsim Control, and we can see the simulation data running in parallel with the live control of the equipment, so of the regulators or the fans. So black box, for example, here of the regulator shows the opening, and then you can see the simulated airflow being affected by the physical equipment. So you could have an engineering station that is running a simulation model to predict your future control needs, and then this SCADA then controls it and optimizes it live. So from this 3D environment, we can also access the controllers, the faceplates directly. Another way to visualize information is through level plans. So for example, you can import your level plan drawings, superimpose your controllers, and then see all the pertinent information, control modes, and then as well, you can access the controllers, of course, to be able to control the fans and regulators. Okay, so this is all done through a configuration process. I'll show you quickly here. For example, under a fan controller, it's all done by selecting the different options and control needs. You just enable those in the configuration, and there's no programming involved. So it's very straightforward and simple to configure. I'll show you a quick example of a type of energy you can generate. So you could have an energy report that gives you the status of the current operation of the fans and the energy consumption, or you can also generate an archive report between 2 time periods. Okay, so I'll show you quickly the 5 levels of control. So let's look at this auxiliary fan. So presently, level 1 control is manual control. So that's what we're doing here. If I change this fan speed to 50%, I have configured in the system an alarm just to show you that alarms are shown pretty much everywhere that somebody can see. Alarms can also be sent to emails. That's an option. So once an alarm has been acknowledged, if the condition is removed, then the alarm will disappear automatically. Okay, level 2 is scheduling control. So here I'll show you quickly the scheduling. We have one event that affects this fan controller. So this event will change the speed from 75 to 70%. So quickly here, we can see that the configuration, you basically select which controller does what, and then you can schedule that in time with a recurrence, or you can start it immediately. So if I start it right away, we can see that the scheduled event has changed that fan speed to 70% at this time. Okay. Level 3 is flow control. So here we're going to switch over to flow control. And basically now I can change the fan's flow set point to 25, for example. And then it automatically increases the speed based on the PID gains to be able to obtain that 25 meters cubed per second set point. There's another option, if I can show you here. I have another controller which has a sensor as a bias. So we have a CO sensor, and this could be any type of gas or temperature reading, for example. We have set a threshold of 9, and we're reading 10, so we have an excess of CO. So if I enable this gas bias, it'll automatically increase. We can see down here in the demand section, it's automatically increasing the demand for that zone to be able to flush out the gases. And we can see that the opening is increasing based on that bias that has been configured. Okay, so that's level 3. If I look at level 4, and that is the ventilation on demand. So here I have access to the tracking that's pertinent to this level. So we can see here at this controller, we have one truck that is on, and based on its configuration, it's providing a 20 meters cubed per second demand in that zone. So if I switch over from this flow demand of 25 to that tracking demand of 20, we can see that the controller will start automatically decreasing the fan speed to attain that 20 meters cubed per second demand based on the vehicle tracking. So the vehicle database here is normally fed by the tracking system. For example, NewTrax, Aruc, Scout, or Ekahau as examples. And then the vehicles, as they're moving, they will provide these demands automatically in the zone. Okay, and the level 5 control, I have another summary page that I have configured just for that. Here we have one fan extracting air from 4 levels. These regulators are all in parallel. So each of these regulators has their own control mode presently, flow or ventilation on demand, meeting their requirements. And the fan is not optimized, it's running at 100% fan speed. So if I open up the controller and then enable the fan speed optimization, it's presently adjusting automatically the fan speed to alleviate the restriction in the system. So we have configured it to look at 80%, for example, of maximum regulator. So what's going to happen is here, the regulators will open automatically up until the maximum of 80%, which will relieve the restriction in the system, and then run the fan speed at an optimal energy consumption. Okay, let me go back to the slides. And let's have a look at the software-hardware integration. So VOD hardware implementation options are either using the mine's existing hardware, for example, Nicoleum South or Eleanor, which are some case studies examples I'll get into shortly, or using Howden Ventsim hardware, for example, Dugald River or San Julian Mine. So there are some advantages of using Howden Ventsim hardware. First off, they're off-the-shelf products, which provides simplicity and compatibility. The Ventsim control software has full capabilities over the hardware. The configurations are easily backed up and restored very quickly. The kits are pre-assembled before shipment, which reduces installation time on site, and there's no programming involved. The requirements to install on site are having a communication network, then having automation, which could be PLCs, remote IOs, or the Howden hardware, having a software license based on control level and the number of devices that you're controlling, having 2 servers, one for control, one for the HMI. They could be also virtual servers, and doing training either Howden or on-site. Additional on-site options are the system configuration can be done by us, or we can train you to do that. The system commissioning is the same. Then there's the software maintenance to have all of the latest features, and we can provide support either remote or on-site as well. So let's look at some case studies to get some real-world examples. So first example is the Fresnillo San Julian mine. They have all 5 levels of control, controlling 15 primary fans, 12 airflow regulators, and all the associated flow, temperature, and gas monitoring. They're saving approximately $200,000 US per year. Another example is the Glencore Nickel Rim South mine. They have all 5 levels of control, controlling 5 primary fans, 199 auxiliary fans, 21 airflow regulators, all the associated monitoring. And their main justification was to increase the production, to be able to manage the vehicle fleet, as well as energy savings. And here we have some examples between 2015 and 2018. They had between $2.5 and $5 million US in savings. So here we have a breakdown of the savings per type of fan. We can also see that peak energy was quite a big contributor in the energy savings, and as well in the cost savings actually, and heating reductions based on airflow need reductions at the inlet. Next example is the Newmont Eleanor mine. They have all 5 levels of control, controlling 6 primary fans, 240 auxiliary fans, 41 airflow regulators, all of the associated monitoring. They have 196 vehicles with RFID tracking. They also wanted to increase their production, and they also achieve very significant yearly energy savings between $4.5 to $6 million US per year. Last year, they were awarded the Eureka Prize from the government for innovation with their ventilation on demand system. Next example is the MMG Dougal River mine in Australia. They have 3 levels of control, controlling 22 auxiliary fans, 24 regulators, all of the monitoring associated. In this case, Howden provided all the automation panels, and as well as the automated regulators. The Fresnillo Saucito mine has 3 levels of control. We're controlling 20 primary fans, 3 regulators, the associated monitoring. Howden also provided the hardware kits for this project. The Fresnillo La Cienega mine has 3 levels of control, controlling 4 primary fans, 2 regulators, 1 door, the monitoring. We also provided hardware kits for this project. The Barrick Cortez mine has 2 levels of control, controlling 3 primary fans on the surface. And next example is the Fresnillo mine, has 2 levels of control with 10 primary fans, monitoring. We also provided hardware kits in this project. And the Glencore Fraser mine in Canada has 2 levels of control, controlling 107 fans on the ground. So as a quick summary, with Ventsim Control, you can increase production by managing your assets. You can reduce energy by optimizing your fans, your heating, cooling requirements, and you can also decrease peak electricity. You can improve your safety, firstly by improving the air quality. You can plan ahead for your mine ventilation needs. You can log and trend all your important data. And now you can take control with a SCADA for real-time control and optimization. So thank you for listening. If you have any questions, don't hesitate to send them at ventsim@howden.com. It'll be a pleasure for us to answer them for you.
Okay, Pavel, thank you very much for a very nice presentation and some very good case studies there. Certainly encourage, this is something that's very much on our radar with planning projects, and encourage any operations or developing projects to consider this as early as possible so you can plan your mine accordingly.
Yes, thank you.
Thank you. Our next presenter is from a company called Telpa Solutions. His name is Mirko Liebtraum. I've been learning more about Telpa Solutions with Mirko's colleagues earlier today, and it's very interesting. Mirko is a chief sales officer with the technology group and is based in Germany. He holds a Master of Science degree from the well-known Aachen Mining University, and has spent the last 6 years investigating industrial digitization and data-based efficiency improvements in mining operations. The Telpa Solutions offer digitization for surface and underground mining operations, and Mirko's presentation on how data changed the world and then mining will cover some of the aspects around turning operational challenges into opportunities. So I'll hand it over to you, Mirko.
Yes, thanks a lot for the introduction. I'm very pleased to be here, and thanks to all listeners and viewers. I just got the opportunity to share my screen, and I will try to do so to not only give a presentation, but also start with the web demo afterwards. So I assume that you are seeing my presentation right now. And I will just try to jump right in. My focus in this presentation is not exclusively to show you the potentials of digital applications in mining, but also where the development of software and digital application is actually going. We know by certainty the number, of course, is discussed, but there are quite a lot of studies which suggest that the downtimes of heavy equipment and assets in mining are causing vast costs, which we have already found digital measures to decrease them. For the average numbers we found in literature and in use cases, that the technical availability per fleet in a mine or per machine is about 82%. The average downtime cost can be $350,000 per day if the truck is down for the full day. Of course, that's a matter of the commodity, and the average operational utilization from our perspective is far lower than the technical availability, of course. And if you look at what the mining industry has been traditionally, it was not about operational efficiency or the actual let's say the actual efficiency in the mine management, but it was more about market opportunity and good deposits. And then when the price of the market was good, then the mine was good as well. But from our perspective, this will change. We have some two of our use cases displayed here, which one is the Estonian oil shale mine, where we discovered that the fleet utilization is actually far lower than what we expected. And the overall efficiency of the equipment is 85% while it is switched on and working. Speaking of that, 15% at least is lost, not in traveling, but in idling time. And then for another use case, we found that for overground operation, it's a rather small one with 30 machines, a few excavators and trucks, of course, that most of the cycles have not been performed in optimal loading stage, and that's vast opportunity for improvement. So what we achieved underground is that's just, not big figures, but we reduced the fuel cost for a machine, and those are smaller machines. So let's consider a roof bolter or a jumbo drill rig, for example, by 7,600 euros per year. And if you consider that for a larger fleet of 50 or 100 pieces of equipment, that's quite some money already. And we optimized the maintenance scheduling for the very same machine and therefore reduced the cost for 1.2 million euro in this mine and per year. So in general, the very first application cases also in the overground area showed us that we are very capable of improving the operational efficiency and therefore provide value to the users of our solution. And the actual story and the title of my presentation is How Data Changed the World and Then Mining. And that is because all these impacts which we have been providing to our partners and customers in use cases have basically been impacting other industries way harder and earlier by digitalization. When it comes to mining, we can already see that there are vast improvements in terms of optimized scheduling and material flow by newer or more modern dispatch system, for example. It helps mining become more safe for collision avoidance and personal tracking of miners, for example. It helps to predict failures. with predictive maintenance, and therefore increases the technical availability of the equipment, and then again the efficiency with which this equipment is operated, and it tracks the performance of the processes and some of the pieces of equipment, and therefore a more direct management is possible, and the efficiency can be improved. And in the end, as you saw in the use case, when the operational efficiency of a piece of equipment is improved, you will have lowered environmental impact by a higher fuel efficiency. So that's the status basically today already. It's not leveraged fully, but all these chances are there. And most of those points are targeting the actual operational efficiency. So, but if you think about it, and if you think about where mining was, for example, 10 years ago, where most of the mines were struggling with basic communication and radio communication infrastructure, it's not basically about what we can do now, but it's about what will be possible in the future and what is not possible today. And if you want to make sure that you understood what digital applications and digitalization is possible to provide, you should maybe check, from my perspective, on other industries. And if you just take a step back and see, for example, how office works developed over the years, and what modern applications such as operational systems, computers, personal computers, printers, and everything made possible, there was a very sharp and fast development of all these aspects. So 1960 to 80s, there was a vast improvement of office processes, and part of the productive or production chains have been automated, and that process basically continued and increased in pace. So with the rise of the internet, a lot of lack in communication has been removed. You can now coordinate and discuss with people all over the world in real time, and instead of sending mail or fax. And the software development after the change of the century was even faster. There were full automation of processes. There were new economies born. The Internet of Things came on the land map, and right now we are in an age where, or the 2010 actually started with a very popular quote that data is eating the world. And we know that from social media, but we also know now with Corona that the remote office applications are getting more and more capable, and it's also the time to increasingly leverage such potentials of digitalization. And if you translate that basically to the industry, you can already see that the same direction is it doesn't matter which branch, all industries are heading to. And that means that the development cycles of products are getting shorter. Yeah, you can see that at IT, Windows versions or updates of your phone OS or your mobile phone in general. Yeah, it's the same with cars. There are new models on the market in a higher frequency, and the same happens to machines. Then the product as a service business model was raised within the last years of the last decade. You have more subscription service. You don't buy stuff, but you lease it, or you have even a pay-as-you-go scheme where you really only pay for the actual value the product is bringing to you, or when you're actually using it. And these are very, very explicit developments, and they are very impressive, especially if you consider that some industries are well advanced in implementing these methods compared to mining. And there are very big benefits coming with it as well. So the focus on the customer has increased. You won't use what doesn't help you, or you won't use what is not comfortable to use. I think a good example for that is driver cabins of LHDs or excavators. It doesn't really matter, like 10 or 20 years ago, those things have been rough. They've not been comfortable. There was no casing on the roof, which prevents you from being hurt from the rough steel. But nowadays they have an AC, they have a radio, they have nice seatings. They're quite convenient to use. And all this is leading to a bigger system, broader system of products, and each product is basically part of the system. And you can see that in IT already, that you can get an add-on and basically improve the capability of your device or the productivity of your device. And you even have, for this example as well, in the mining industry, add-ons you can put on your machines, like data logging, so you can even make machines drive autonomously with additional hardware and sensors and whatsoever. And in the end, and that's also where we are as Talpa Solutions have been very successfully in the market so far, is that analytics is a competitive advantage. With the data you have at hand, if you really apply it and you put it to use, you can see where your operation is really lacking in efficiency or where more potential can be, and implement that, making a profit to your company. And what we are basically, or what we have been identifying, is that there's a lot of data outside in the mining industry, in the heavy industry in general, which is not used. And it's not only been not used, it's also not collected. So for mobile assets, which is currently our main focus and our key expertise, there's a more or less standardized system and communication scheme, which is not stored in any data logger most of the time, and more crucially, not transmitted. So this data is not used externally from the machine, but also only for machine communication. And if you are able to log this data with the proper timestamping and extract it from the machine, you can really put it to work, see what the problem with your machine is, when the problem has occurred, see what synergies are there with the current state or with the future state, and also check on the performance of the machine and see when performance lags occur and remove them. And this is basically from the components of the different machines, translatable in different industries. And therefore, if you, for example, check out logistics, how high the degree of tracking and digital features is already now, and in agriculture especially as well, that's what's coming towards mining as well. So our approach is to not only source this data, but also, of course, to provide the insights which are needed from our partner and clients to solve the most pressing digital pain points, or even the operational pain points they are having. They're not sure how to solve them yet, but we can put data to work to make that successful, rather than being challenged by digitalization and not sure how to apply it and not sure for what purpose. That's our approach, and I think it's more and more spread also in the mining industry, that these potentials are there, and we are here to leverage it, and we did so very successfully so far, and we're looking forward to have more exciting projects. So what that actually brings is, especially in mining, you have a different, let's say, relation to your equipment. Underground, you're not sure where it is, at what time, you're not sure what it's doing. Of course, you need the baseline of productivity, but we did develop a platform, and I will try to maybe make this a live presentation where you can log in and then see what your assets have been doing in the last time. So you have this landing page where you can see where the machine has been situated, in which level of the mine. This is basically an overground scenario. You see there's a small fleet integrated just so for showing purpose. We're not showing customer data here, which are not compliant with us using it for marketing. You see the OEM, and we are OEM agnostic, so we are not really focused on one product line of one OEM, but we want to bring together all the data to bring the highest possible benefit to the customer. And then when you want to check on the performance, you can build, these are basically modular dashboards. You can set your own dashboard up to see which equipment you would like to track. You can see that the equipment here, for example, has not been switched on in the chosen time frame. We can even choose a longer time frame, for example, and then you see in one click what machine has been the most productive or the less productive, and what the distance and the fuel consumption have performed in the last week. And this, of course, is an overview of all the equipment, which doesn't really make sense to compare an excavator with a dump truck. But you can, of course, have also exclusive view on single machines and see how they have been performing. It's pretty straightforward to click. You should see how many hours the machine has been online, at what time. You can see how much time was spent in which state. You can even check on it in detail, because this are aggregated over the full days. But here you see the sequence of activities, and there's a lot of more stuff going on, but unfortunately the time is running, which might be interesting. You can have a material flow tracking here by geofencing overground or underground, by having sufficient access points available, and track the machines where they have been operating. Maybe one last suggestion here. I mean, there might be some engineers around who are very interested in machine data, actually engine data, for example. And you know that this data can be very valuable when it comes to failure identification, and we put this system in a way up that you can basically select from all days where data has been collected in a few seconds, access the data and see what might have been the issue. So that's basically a tool to remotely analyze the errors of the machines and help the maintenance staff to know what's going on before the machine is in the workshop. So I have some screenshots here, which I'm not going to go through. I want to wrap it up. We are already successfully applying digitalization in mining, and we are looking forward to perform more projects and source more partners to implement open platform, which can be integrated to other solutions, but also can integrate other data sources. So to really focus on the highest impact and the highest benefit to our customers. That's basically it from my side. I will stop sharing my screen and looking forward to your feedback.
Many thanks there, Mirko.
Thank you.
I was really glad to see that slide that you brought up and mentioned that there's still a lot of projects, operations out there not collecting the data, or if they are collecting it, doing enough with it. So, there's a long way still to go there, and opportunities to be realized by companies.
Yes, for sure. I mean, there are publications available which even address or assume that there's only 1% of industrial data actually utilized, and that's I think shocking if you consider what potential lies in that data, right?
I also think 15 minutes doesn't do justice for these technical topics. So please feel free to get in touch with the Talpa Group.
Yes.
After the presentation or in the future.
Thanks for listening. Bye.
Thank you very much. So the next presentation is from a very good friend and colleague for over 12 years from the SRK UK office. He's a principal mining engineer. He is significant, Jurgen Fulkschott. Even after 12 years, I still have trouble pronouncing his Dutch surname. He has significant experience working on a wide range of technical and due diligence projects, and was previously working at operating mines in Australia and Africa. His presentation today will cover a range of remote mining support options to consider for developing and operating mines, with some case studies. So I'll hand it over to you, Jurgen.
Thank you very much, Chris. I think I'll go straight into it. I'll promise not to read every word in the presentation. There's time for that afterwards. What I'd like to talk about is remote mining assistance and the reasons why. Remote mines often have difficulty recruiting professional personnel for the reasons that, especially when you're in Africa, long fly-in fly-out rosters might not align with family reasons for people. And the other thing is that you don't always need highly experienced personnel in specific disciplines, such as, for example, geotech or structural geology, on site all the time. What we've seen recently as well is that with travel restrictions, people have been either stuck on site or stuck at home or stuck in totally different places. And, which for certain people made it hard to actually still do their job if the systems weren't set up. So what I'm going to talk about and highlight some aspects is hopefully not a solution just for these times, but I think that the way we are working as mining professionals will change. So here's the definition. I kept it open more than just ad hoc support by consultants, contractors. It's the use of off-site personnel to assist the on-site personnel with cooperation, review, and advice, with training, and with something that's often more site visit related, data gathering and the inspections. This can be done internally within a company or externally using consultants, contractors, etc. One of the main requirements that you have is the transition from local server-based data to cloud-based data, so everybody can access it all the time. That has to be done within a strategic plan for the digital transformation. And just on the right, there's that picture from Geovia where you have standalone apps like, say, Serpac Mineshed, which are on your machine, which might use local data. Put the data in the cloud, and even the apps will be in the cloud as well. So that comes back to Mirko's presentation, where you don't buy a software package anymore. You buy a subscription where you say, well, I'm going to use it for 5 days here. So you only pay for that bit of time. I only buy those units. So here's the ideal world where everything is perfectly connected. Word of warning. When we're talking about digital transformation, please keep that long-term target in mind, but go in steps, right? Yes, you can start collecting all the data and lose the end target, or you can even just have high aspirations and get stuck because it's just too hard to achieve. Pick a pilot project and start working on that. So some of the aspects here are digitized geological data, mining, scheduling, etc. That is often already in digital form, but there are sites which don't have that yet. Mirko talked about the IoT sensors for the data capture, and something that SOK has been focusing on has been the utilization of drones and action cameras for site inspections. And then hopefully that all goes to that connected workforce, which actually can use their mobile devices, which are far more powerful than they ever were before. And then in the end, then you hopefully get a digital twin. So you build your mine in a digital way. So for all your simulations, rescheduling, all things like that. Some buzzwords: platform as a service. So not only will you put your data in the cloud, you might even put your applications in the cloud. So you're not dependent on your laptop anymore. You have subscription-based computing power. I'm not going to go through in very much detail, but yes, in the bottom left-hand corner, there's your maintenance. That can go into the clouds, like Mirko has shown. Your finances, etc. And we'll get back to that in a moment. So what are the advantages? So you put all your data in the cloud, people can access it. And what now? 3 S's: sustainability, security, safety. If somebody doesn't have to come to site, there's less air travel, there's less road travel. Most of the accidents that have happened to our consultants have been on the road. Less personnel on remote sites will increase safety. Some of those remote sites are less secure locations where you may not want to travel to. And one of the biggest things is you get more effective and efficient use of personnel. You only use the specialists when you require them. If somebody can do a virtual site visit for 2 days and doesn't need the day before and the day after, you've saved half the cost, and which might even spend on more processing time, more evaluation time. The other advantage is if you use people who are offsite, and that can be within a company, like if you have multiple sites and have one engineer looking after 3 lines, you get this cross-fermentation where the offsite personnel has got more exposure to the techniques, becomes more experienced because they've seen this thing happen before. Oh, remember this thing from 10 years ago, let's use that. And as I said, you might be more flexible with fly out. Even for those people working in the office, avoid the traffic jam. Leave earlier, finish it off at home, pick up exactly where you were when you left the office. There will be less interruptions to the design and scheduling processes. If you're a multinational company, you might even be able to use the advantage of time zones. Somebody on the other side of the earth can continue with the work. Pending software supply, you might be able to share software licenses. And you can, with the right platforms, you can shield certain information so people can look at it, can't touch it. Only those who've got the right level of authority can actually modify that data. Speaking of data, it's the first part of the digital transformation. As I said, there have been mines, or there are still mines, where all the plans are done, even on paper. The planification might be done in AutoCAD. It's not done in any mining software. So, as somebody said, managing a mine is about managing data. And it's not just data. You know, it's fine to have lots of data, but you want to turn that into information, make it useful. So if you get that data into the right software, the right platform, it becomes information, and it'll allow you to respond quicker to changing economic circumstances. Gold price that change. Oh, my grade is not what I thought it was going to be. My recovery is not what I thought it was going to be. What if this continues? What's going to be the effect? All good and well to have that technical data into a system. The other thing you want is the mind of the people. It's called mind mining, where why was this decision taken? Why have we taken this pit design and not that pit design? Why we have taken these trucks and not that truck? And if somebody leaves site and all that knowledge is inside his or her head, you get loss of information. It's not even data, it's information, knowledge. One of the buzzword again, end-to-end digital connectivity is something from Jovia, where you look at the whole company, the data flows, the material flows. They split it up in 3 areas where you've got the capital, which is required for your operations, the resources, which, where you get your geologists and after that your mining engineers working on, and then you get your day-to-day operations, which is very much linked to what Miyoko was saying. There are steps. Pick a pilot project and start with the next one. So, but think of that. What do you want to achieve? What's the aim of this program? Who do you want to talk with? Do you want to only talk within your company? How many contractors will you have? What data formats are you using? One of my colleagues mentioned that she has been working within a company on different mine sites, and the level of data stored and the methods stored were all different. You want to align within a company first before you even start going externally, or let somebody who's got that experience help you to get all on the same playing field, so people within the company can work better with each other.
Sorry, Jürgen.
Yeah.
We'll have to keep moving through the slides to stay on schedule.
Yeah, will do. Okay, Mirko has basically covered this very well. One thing, have a backup. The reason why I showed the Mars rover, which is a $2.5 billion project, when NASA had to shut down because of COVID, people couldn't use their fancy 3D glasses anymore. They had to get back to the red and blue 3D glasses, and they finished their drilling program. Some of the issues, fragmentation and duplication of data. If you have a platform and you've got 3 different block models and there might just be slight changes between them, and you have not perfectly aligned what's the latest version, somebody might be using the wrong block model or the wrong design. There might be geographical constraints where certain video software can't be used. Data security is a big one as well, especially in the light of a company which has recently been hacked. Proprietary formats, we talked about that. Hopefully the open mining format can be used in the future. There might be too much data. Mirko said only 1% is used. Well, how much of the other 99% do you really want to use? And the other thing is the work-life boundary is dissolving. If you can work all the time, because you've got access, do you want to? Yes, I've got 14 different ways of contacting people. Right, quick example, as done by SK South Africa, where they had a tailing storage facility surveillance, where they built a digital model of the tailing storage facility with satellite photos, 3D designs. They were measuring the piezometers, the water levels in there. That then became a dashboard where those water levels could be seen. They could go back in history, see the transition of the tailings dam. A system like that can be accessed from anywhere. This case was done in ArcGIS, which is another one of the platforms. The way forward is that you can combine in ArcGIS your drone surveillance, your normal surveyors, your satellite data, people walking on the ground, taking photos, have all that and be able to retrieve and go back in history. Another example of cloud-based data that has turned information and then into action is the Whole Road Explorer, which is a partnership between MTS and SRK, where the operating speed of trucks is being logged by mobile phones. As I said, they're very powerful. This data is then compared with the design speed, visualized at heat map. So in the bottom left-hand picture, you can see where in red, it's slow. Well, yeah, it's a sharp turn there, but trucks are not picking up that much speed as they should be. What's happening with the road there? And what then can be done as well, that you can have paperless inspections on a mobile again, where the additional information is being used to confirm what we're seeing from the measuring data from the trucks, where actually the shift balls or any operator can take a photo and say, well, this is actually what's happening. And that can then be translated into an action of sending a grader there or fixing berms or putting traffic signs there. And that's it. So basically, hopefully, we'll get to the stage where we can work from home, we can work from the office, we can work from a mine and do what we like doing. Thank you for your time.
Thank you very much, Jürgen. There's a lot to think about there. And I like case studies where you're seeing extreme examples like operating on Mars with autonomous equipment. You know, world's first autonomous underground mine is developed over in Mali, and you just see those case studies and think, well, if they can do that, then the challenges we have most of us face are not so challenging. So on that note, we'll move over to the next presentation there. Unfortunately, I haven't had a chance to speak with Dr. Ana Mladenovic in person, but she is head of laboratory for stone, aggregate and recycled materials, the Slovenian National Building and Civil Engineering Institute. Dr. Anna has a background in geology and more than 30 years of experience in the field of characterization of materials such as aggregates, natural stone, cementitious composites, and particularly waste recycling. Dr. Anna will be presenting the RIS Restore project, which is assessing the reprocessing of red mud, assume that's bauxite tailings, in the East and Southeast Europe region for recovery of valuable metals. Over to you, Dr. Anna.
Thank you very much, Mr. Chairman. Good afternoon, ladies and gentlemen, and thanks to the organizing committee for inviting me as a lecturer. So I'm going to present an interesting ongoing project which we would like to promote it through the MINEX forum community. So it is the RIS Restore project, which deals with red mud tailings in the EC region. EC region means East, Southeast Europe. And then extraction of valuable metals out of these tailings. This is the topic of the project. So this project, just to find the bottom, okay, it works. This project is running under the EIT Raw Materials program. As you might know, EIT means European Institute of Innovation and Technology. And this is the European body established in 2008 with the aim to enhance the ability of Europe to innovate. And this is a first initiative that brought together all three sides of the knowledge triangle. That means industry, of course, and then also research institutes and academia. And EIT, as a mother, then established several communities, and one of them is the raw materials community. And this community, the aim or the main activities of this community are focusing on the raw materials value chain, from exploration, mining, processing, recycling, substitution, and eco-design. There are six collocation centers across the Europe and the headquarters in Berlin. And since 2014, the EIT Raw Materials has granted many projects on the activities that I have just mentioned. There is also a sub-program called RIS scheme or RIS program, which is dedicated to the countries which have been considered as modest or moderate innovators. As you can see from this picture, many countries belong to this group. These are these green colored countries. And also our project, RIS Restore, is running under this scheme. And now let's go to the project itself. First, a short prologue in order to understand why we are working on industrial residuals or waste material. So the main push is that our project, our planet is running out of room and resources, and that we have many threats like climate changes and growing population, resource depletion, the resources need to be doubled by 2050 due to increasing population. And then the Europe has additional its own problems, lack of natural resources. Europe is a net importer of raw materials. On the last list of critical raw materials are 27 elements. On the other hand, the Europe has already recognized the paradigm: waste is a resource, waste is a raw materials, and especially in the light of huge quantity of waste that is generated every year. So the topic of this project is red mud from alumina production. This is industrial waste, and in EC region it is estimated that there is almost 85 million tons of this material in several countries, in Hungary, in Bosnia and Herzegovina, in Montenegro, in Greece, in Slovenia, in Croatia. And it is well known that these tailings, these dumps, are quite serious hot spots. Some words about red mud. This is waste that were or is generated during the digestion of bauxite or in Bayer process for the extraction of alumina, and alumina is then a feed for aluminium production. And it is estimated that 1 ton of produced alumina generates up to 2 tons of red mud. So really a large quantities. As I said before, quite severe environmental hotspots. You may remember Ajka, Hungary, a catastrophic event a few years ago where a spill of red mud happened. But these tailings, this red mud, contain valuable metal. Amongst these valuable metals are also metals which are on the list of critical raw materials. So these are preliminary data for red mud tailings in the EC region. You can see rare earth elements and other metals. And these metals are mostly embedded in or associated with heavy minerals. So these restore activities are divided into technical activities and into kind of networking activities. The technical activities will be in 3 steps. First step is evaluation of selected tailings in selected countries in order to get the information about the distribution and quantity of these metals. This will be done based on historical data and in situ sampling. The second step will be extraction of heavy minerals on sample, probably from landfill from Podgorica, Montenegro. Of course, this should be cost-efficient process. We are aware of that. And the third step is utilization and beneficial use of remainings after metal extraction and use these new materials in building sector. mostly in earthworks. So the aim is, in the end, no solid or liquid waste. And then a few words about consortium. 11 partners from 9 countries, plus 9 task partners from the EC region. Task partners are entities who are not regular partners of EIT raw materials. These are mainly partners from the Balkan region. And then some more strategic aims of the project. We need to establish a self-sustaining network of the stakeholders and interested entities in the region. We have to draft a kind of regional innovation scheme for these activities. And then the other 2 activities will be raising awareness among the people and show them opportunities which this model offers when it's on the table. And of course, we would like to increase the capacity building of organizations and also local society again in this region. So this is a short presentation of the project. If you see any possible synergies or if you are interested in the project, please contact me. Thank you very much.
Thank you very much, Dr. Anna. I'm sure there's a lot of clapping going there in the background on a very positive project and topic. And we look forward to hearing more of your progress in the future.
Thank you.
Okay. Thank you very much. Just catching up on the last presentation now, I'd like to introduce Mr. Thomas Pavlik, who I certainly haven't made contact with yet, but looking forward to hearing his presentation on a range of research and development projects and technologies with a focus on mining efficiency. Thomas has worked his way up from researcher to project head of the Faculty of Mining, Ecology, Process Control and Geotechnologies with the Technical University of Košice in Slovakia. He's also a director of the one of the EIT initiatives that Dr. Anna was presenting on as well. So I'll hand it over to you there, Thomas.
Yeah, thank you very much. I'm going to have a related presentation like Anna had because it concerns on EIT raw materials and the projects under it. But I'll start more with the importance of raw materials for now. Yeah, I have no doubt that everyone in this community is highly aware of the importance of raw materials, but let me at least briefly highlight this sector at the beginning so that each of us can realize again. Let's realize what happened during the COVID-19 crisis. Feel free to play your personal situation in your head. The borders of the countries have been closed from day to day. We couldn't travel anymore. Most of us have stopped going to work. Our children stopped going to school and started learning from home. And we were also forced to work from home. Events, webinars, and conferences like this must be held remotely. So how lucky we are to have the internet, computers, and smartphones, and other stuff, right? But like all of us here, we know that these devices and systems could not work without the content of metals and raw materials. I cut it short no internet, no modern means of communications, no current means of transport, we wouldn't have such resources as copper, aluminium, lithium, cobalt, and many others. By the way, did you know that 12 of the 75 elements in a smartphone can be replaced in any way? It is quite interesting fact, but also disturbing. And on average, a person consumes up to 1.37 million kilograms of raw materials, and this is the approximate weight of the six largest civil aircraft, Airbus A380. Well, can you imagine that weight? And also, with arguments as to why raw materials are important, I could go on and on. But the fact is that without raw materials, after the outbreak of COVID, we would simply be cut off from the world, from civilization, and we would wait at home. Of course, we couldn't have homes as such, because in addition to steel structures, cement and concrete also contain metals. And in fact, we probably wouldn't exist without raw materials either, because the core of the Earth needs iron and nickel, otherwise there would be no magnetic field. And in order for the ozone layer to hold together, a magnetic field is essential. And also, our body contains about 3% of such raw materials like potassium, sodium, zinc, iron, and our brain needs, for example, magnesium to keep its attention. So I really hope you have, believe you have enough magnesium right now to keep your attention. And as I'm the last presenter of this section, but the key message: why raw materials? Because without them, it would be literally a nightmare. However, we are lucky that all these questions are just hypothetical questions, and we have raw materials at our disposal. But who still doubts that raw materials needs to be mined? Raw materials are here, and all we have to do is to get them from Earth and use them for life in a sustainable way. That's important. With regards to social license to operate, these considerations led me to the following possibilities. We must look for environmentally friendly ways of mining that will provide sufficient resources for our children and their children. And the second dimension of that is the technological process must be environmentally friendly, or eliminate the negative effects as much as possible with the principles of the circular economy. At the same time, these technologies must be cost effective, because this is the basic motive of every business entity, but also of states and countries. And thirdly, we must seek substitution for existing resources that are already at risk. For some reason, like Europe is unable to secure their self-sufficiency and must import some raw materials from China, from United States, and from other countries. We really need to work together to address these challenges. And through the EIT raw materials, the European Commission seeks to bring together the best experts from across Europe to address these complex issues. Our center, EIT Raw Materials Regional Center Košice, also has its regional network of the best in its field, and these are basically universities, researchers, small and medium-sized companies, non-governmental organizations, and individuals. Not everyone is focused primarily on mining. In the network, we have a mixture of entities that cover the entire value chain of raw materials, from product or service design, through extraction, up to reuse and recycling. Any of you can join this network. Most of you certainly have a lot of ideas and projects that would like to solve if you just lack partners, finances, or other kind of support. But the critical point is mostly any collaboration is somehow to begin. As proof that this is possible and relatively simple, I will give you an example from my personal experience. I came to the Faculty of Mining, Ecology, Process Control and Geotechnologies on the Technical University of Košice to work as a PhD student in 2013, after working for the private sector for a few years. And around 2015, the dean of the faculty changed, and the new dean said raw materials as a priority for the faculty. At the time, I didn't really know what he meant. However, our management saw potential in the EIT raw materials community, and I was to be an executive component of what constitutes activity in this community. So we started working on the project proposals for the EIT raw materials grant scheme, and the management of the faculty worked on the new context, and I worked to ensure that everything was formally secured. Everything was also new to us. We didn't know what some of the abbreviations meant, how exactly such grants are submitted, and so on and so on. We started in the community in 2015, and already in 2016 we had the first projects approved. We also had to take projects that were not very beneficial for us, in a way that it cost us more energy than we benefited, but it was very important that we proved to be a reliable partner. And soon the offers to the project consortia began to come on their own. If you get through this phase, you will receive several invitations to a project consortia from other partners each year. To date, I would like to say that to date we have received 19 projects under EIT raw materials with a total funding of more than 1.3 million euros for our university alone. In addition, the regional hub center Košice has been operating on our university since 2018, and all this happened in just 5 years. What I think that's not bad. And of course, these projects are not just about us. They are mainly about the involvement of a local community of partners who have not even heard of EIT raw materials before. For example, the Minetalk project, where Eurotalk company wanted to address an innovative mining technology and multi-layer backfilling. And this company became involved in the project proposal. And only when the project was approved for funding, the company became a member of EIT raw materials. The project received funding of almost 3 million euros. Or the project Enact SDGs. As part of the project, we are building the dynamic network composed of industrial, research, and academic local partners who can actively participate in the formation of raw material study programs in the country of Eastern and Southeastern Europe. Or similarly, the projects like MEXAMP or DIM-ESE, where we involve our local industry partners to help shape the graduates they need for current and future industries. Last project I will mention is the LIMPRA project, where we are trying to prevent brain drain, talented young people with the potential to start their own business in our region. And we also managed to mediate their partnership for this project for the Technical University in Ostrava, who previously had no experience with EIT raw materials and now have they have an allocated budget and are active in the network for other project proposals. So how to be engaged? Just contact our center. We can mainly mediate cooperation into areas of networking and matchmaking, educational activities, and in the area of business creation activities like startups and so on. On our website, in the section activities, and there is a partner form section, you can leave there your information as well as a basic description of your activity or your idea for cooperation. And after submitting the form, we will add you to our network, and we will contact you shortly to find a common intersection. And okay, and to wrap up, if we want to achieve the sustainability of raw materials extraction, we must definitely work together. And the future of global industry really depends on a sustainable supply of raw materials. This is an extremely important vision for the countries of Central and Eastern and Southeastern Europe. So that's basically it. And so share your ideas and make innovation happen. Thank you.
Thank you very much for the positive message there. And I do really think it makes a lot of sense, the employment opportunities that you're creating, with those projects for professionals and also local communities. I think
thank you.
In the future. Arthur was promising 10 minutes of questions and answers. I don't know where you sit there still. Thankfully, thanks to the presenters, especially the later ones, have caught up on some of the time I lost earlier, which I take full responsibility for. But are there any questions from the group that we can put forward to the presenters?
So, Chris, this is the opportunity for presenters to answer any questions they wanted to mention during the presentation. If there is no comments or there's no questions, then obviously I'll do a short summary. But the floor is yours. Maybe actually you had some questions you wanted to answer, the speakers to answer.
Well, I did have a few that sort of came up through the presentations there. On the ventilation presentation there, Pavel, I was just curious how your ventilation controls for are developing. Are they continuing to evolve with the battery electric vehicles having an impact on ventilation in underground mines? What are the big changes that are happening with Howden these days?
I think, Chris, you need to invite all the speakers to turn their microphones on, because they've been very obedient and they had their microphones off. So let's just ask them to turn their microphones on. Thanks.
Okay, Chris, for the you were asking for the ventilation on demand and battery electric vehicles. For sure, these have an impact, and we are currently doing some studies on that end to be able to provide the energy efficiency in terms of using electric vehicles instead of diesel. And so the system can be configured to have both. For sure, there's going to be a transition period to have this transition. And it's going to take some time, but for sure there are some advantages of using electric on the ventilation side, where you can have provide more air and reduce the energy consumption.
Yeah, it's definitely an area where we're learning as the technology develops as well. So, but it really is having a significant impact on just our ventilation studies for new projects and so on. So. I guess you're in the right spot there over in Canada, where a lot of these technologies are developing.
Yes, definitely.